In this video, we are going to discuss about the evaporator. Evaporator is one of the four important components of chiller. First, let's see what an evaporation is. When water is heated in a vessel, it evaporates little by little and changes from liquid to gas. The process of changing the liquid to vapor is called evaporation. The refrigerant is heated in the evaporator and it evaporates from liquid state to vapor state. That's why we call it evaporator. First, let's look at the design of the evaporator. There are three types of evaporators: shell and tube evaporator, cone type evaporator, and plate type evaporator. Shell and tube evaporator is mostly used among these three evaporators. The outside of this evaporator is in the form of a shell, and inside there are coils. This is why we call it shell and tube evaporator. If water enters from one side and exits from the opposite side, it is a single-pass evaporator. If the water that comes in from one side turns 180 degrees on the other side of the evaporator and comes out through the same way, it is a two-pass evaporator. Similarly, there is a three-pass evaporator. In two-pass and three-pass evaporator, the water travels for a longer time, so more heat transfer takes place and more efficiency is obtained. This is water box. Water enters through its inlet and comes out through its outlet. There is a plate in the middle to keep these two waters from mixing. The name of this plate is baffle. Both ends of the evaporator are sealed by a plate to prevent refrigerant leakage. Water coming from the AHU enters through the inlet. This water travels across the coil. The refrigerant from the expansion valve fills the evaporator through the inlet. This refrigerant surrounds the coils inside the evaporator. Since the temperature of the water in the coil is higher than the temperature of the refrigerant. As per the law of thermodynamics, the heat of the water will go to the refrigerant. Therefore, the temperature of the refrigerant will increase and the temperature of the water will decrease. Refrigerant's boiling point is very low, and as its temperature increases, it evaporates and turns into vapor. Then, from there, it goes to condenser with the help of compressor. The cooled water from there goes to the AHU. This is the working principle of the chiller evaporator. I hope you understand this video. There is no major difference between evaporator and condenser. Both have the same design. Only its working is slightly different. First, let's see what condensation is. When water in a vessel is heated, the water changes from a liquid to vapor. In the previous video, we explained this as the evaporation process. The reverse process of evaporation is the condensation. When water in vapor state is cooled, it turns back into liquid state. A good example of this is rain. Due to the heat from the sun, the water in the earth evaporates into vapor little by little and goes up. As the vapor rises, the temperature decreases. So, vapor turns into liquid and falls on us as rain. The refrigerant, which is in vapor state in the condenser of the chiller, is cooled and condensed into liquid form with the help of water from the cooling tower. That's why we call it condenser. Now we can see the differences between evaporator and condenser. In the evaporator, the water from the AHU comes in as an inlet. In the condenser, the water from the cooling tower comes in as an inlet. In evaporator, refrigerant enters from bottom. In condenser, refrigerant enters from top. In some of the latest chillers, the refrigerant comes in from the top of the evaporator. In the evaporator, the refrigerant is heated. In the condenser, the refrigerant is cooled. Condenser is also shell and tube heat exchanger. This also has water box and baffle, and both ends are sealed to prevent refrigerant leakage. Now let's see how it works. Water from the cooling tower enters into the condenser and travels throughout the coil. The refrigerant coming from the compressor enters the condenser at high temperature and vapor stage. The refrigerant is at a higher temperature and the water inside the coil is at a lower temperature. When the refrigerant falls on the coil, according to the law of thermodynamics, the heat in the refrigerant goes to the water in the coil. As the heat of the refrigerant goes to the water, the temperature of the refrigerant decreases and changes from the vapor state to the liquid state. Then, refrigerant will go to expansion valve after changing to liquid state. The heated water goes to the cooling tower, where it is cooled and returns to the condenser. This is the working principle of the condenser.
Expansion valve is an important component in an AC system. There are three types of expansion valve: thermal expansion valve, the electronic expansion valve, and fixed orifice expansion valve. We are going to explain about the thermal expansion valve, which is the most commonly used expansion valve. It does two important jobs. One is, it expands the refrigerant and reduces its pressure and temperature. Another one is, sends the required amount of refrigerant to the evaporator. How can the temperature of a refrigerant be reduced by expanding it? Let's do a little experiment. When we blow air, like in this first picture, we can feel some hot air coming. As in the second picture, when we blow air, we can feel some cold air coming. When we compress and release hot air, the temperature of the air will drop. Similarly, when we compress and release the refrigerant, the temperature of the refrigerant decreases. When 4 people enter a room where AC is running, the temperature of that room increases. At that time, the expansion valve sends more refrigerant to the evaporator and cools the room. After everyone has left that room, the expansion valve will reduce the amount of refrigerant going to the evaporator, as the room does not need more cooling. First, let's know its parts. This is thermal expansion valve. This is the inlet through which the refrigerant enters. It is the outlet through which the refrigerant goes out. This is the main body, inside which there is a spring. Refrigerant flow control is done through this spring. This normally keeps the refrigerant passage closed. This is an adjusting valve through which we can adjust the spring manually. It is a thermal bulb that has a refrigerant inside. It is a small tube of about 1 millimeter diameter. It has a diaphragm inside. Diaphragm means it is in a round disc shape. Now let's see how it works. The thermal bulb is connected to the outlet of the evaporator, like this. There is a refrigerant inside this thermal bulb. The refrigerant used in the thermal bulb is the same refrigerant used in the AC unit. For example, if R410A refrigerant is used in the AC unit, the same refrigerant is used in the thermal bulb. The refrigerant that enters the evaporator is heated and converted into vapor and exits. A thermal bulb is attached to the evaporator outlet. When the outlet heats up, heat is transferred to the thermal bulb. At that time, the refrigerant inside the thermal bulb will begin to boil and turn into vapor. All this vapor comes through this small tube to the diaphragm in the expansion valve and pushes the diaphragm down under high pressure. This diaphragm is connected to a spring inside the expansion valve. When the diaphragm is pressed down, this spring is also compressed. Now, the refrigerant part increases and more refrigerant goes to the evaporator. Hence, the evaporator coil also cools down quickly. After the evaporator coil cools down, its outlet part also starts cooling down. So, the refrigerant inside the thermal bulb will stop boiling and the pressure will be released in the diaphragm. Now, the diaphragm will come up due to spring force, and the way of refrigerant will be closed. This is how the thermal expansion valve sends the required refrigerant to the evaporator. The part that the refrigerant can travel through is very small. It compresses and releases the refrigerant that can travel through it. Therefore, as we have already mentioned above, the pressure and temperature of the refrigerant decreases and the cooled refrigerant goes to the evaporator. And one more point is that when this passage for refrigerant is closed, it does not close completely. There is a small gap through which the small amount of refrigerant continues to flow. Only when the temperature of the evaporator increases, this gap increases and more refrigerant goes to the evaporator. If you find it difficult to understand, please ask your doubts in the comments and get clarification. The different types of compressors used in HVAC systems. Compressors are often called the heart of an HVAC system because they play a crucial role in compressing the refrigerant and facilitating the heat exchange process. So, let's break down the 5 main types of compressors you'll commonly encounter. Reciprocating compressor. This is one of the most widely used compressors in HVAC systems. It operates using a piston and cylinder mechanism similar to a car engine. As the piston moves back and forth, it compresses the refrigerant gas. Reciprocating compressors are durable and efficient, making them a popular choice for small to medium cooling applications. Scroll compressor. It is known for its quiet operation and efficiency. It uses 2 spiral-shaped scrolls, one stationary and the other moving to compress the refrigerant. This unique design reduces noise, increases reliability, and provides a smooth flow of refrigerant, making it ideal for residential and commercial HVAC systems. Rotary compressor. This type is compact, efficient, and commonly used in smaller air conditioning units. It uses a rotating mechanism, like a rolling vane, to compress the refrigerant. Rotary compressors are highly reliable and are often found in window and split AC systems. Screw compressor. The screw compressor, which uses 2 interlocking helical rotors to compress the refrigerant. This design ensures smooth, continuous operation and high efficiency. Screw compressors are commonly used in medium to large cooling systems, such as industrial chillers, due to their reliability and ability to handle significant loads. Centrifugal compressor. Unlike the previous types, this compressor uses centrifugal force to compress the refrigerant. A rotating impeller accelerates the refrigerant gas and pushes it through a diffuser to increase pressure. Centrifugal compressors are typically used in large-scale cooling applications, like chillers for commercial buildings. To recap, we discussed the 5 main types of compressors in HVAC systems: reciprocating, scroll, rotary, centrifugal, and screw compressors. Each type has unique characteristics and is suited for specific applications. In our upcoming videos, we'll dive deeper into how each of these compressors works. We are going to discuss about the working principle of cooling tower. There are commonly 2 types of chillers: air-cooled chiller and water-cooled chiller. Water-cooled chiller uses water from cooling tower to reduce the refrigerant temperature inside the condenser. Likewise, the refrigerant temperature of air-cooled chiller is decreased by air instead of water. The efficiency of water-cooled chiller is greater than the air-cooled chiller, as it uses water, which is comparatively quicker and better in decreasing the temperature. Let's see the parts inside the cooling tower. Fan motor. Fills. Nozzle. The water from the condenser of a chiller is entered through the inlet pipeline into the cooling tower, which is sprayed upon the fills through nozzle. The sprayed water is then traveled downwards through the fills. As the fan inside the cooling tower rotates, it removes the air from inside the cooling tower. The fresh air travels through the fills and enters the tower, which reduces the water temperature, which is flow through the fills. The water enters the tower with 35 degrees Celsius, will be reduced to the 30 degrees Celsius when it leaves the tower. Thus, the water will reduce the refrigerant temperature inside the condenser of the chiller and then returns to the cooling tower. These processes are continuous. This is the working process of cooling tower. AHU means air handling unit. Air handling unit is as similar to the indoor air conditioner and has the same working principle. Usually, we will select split AC to install at home. Likewise, for larger buildings and larger areas, we will select AHU. The AC ton, we will decide by the size of the room. For example, 1 ton AC is needed for a 10 by 10 feet room. The AHU ton is also decided by the size of the area where it needs to be serviced. The size of the AHU depends upon the ton of the AHU. The parts of the AHU are: motor blower. It is used to blow the air from AHU to the room. Filter. It is used to filter the dust from air. Bag filter. It is used to filter the minute dust particles from air. Coil. Chilled water from the chiller is traveled through this coil. AHU uses the cooling from this chilled water to distribute the chilled air to the rooms. The working principle of the AHU. The blower motor in AHU supplies air to the room through the supply duct. The hot air from the room returns to the AHU through the return duct. The normal temperature of air is 24 degrees Celsius while entering the AHU. It travels through filter at first. Now the large dust particles in the air are filtered. Then, the air travels through the bag filter. Minute dust particles are filtered by the bag filter. Once filtered, the air will travel through the copper coil. While traveling, it absorbs the cooling from the coil and leaves at 18 degrees Celsius. By using the blower, the cooled air is supplied to the room through the supply duct. Again, the hot air returns to the AHU through the return duct. This cycle is a repetitive process. This is the working principle of the air handling unit. Refrigerant is used in devices that can remove heat like AC and fridge. refrigerant can be in gas or liquid state depending on the temperature. The important job of refrigerant is to absorb the heat in the area where we want to cool. Initially, dangerous refrigerants like ammonia, sulfur dioxide, methyl chloride were used in AC and fridges. When such a dangerous refrigerant leaks, it causes more danger to the bystanders. It can even cause death. Thus, the first non-flammable R12 refrigerant was invented and used in 1928. Chlorofluorocarbon chemical is used in this R12 refrigerant. In 1980, it became known that this chlorofluorocarbon chemical is damaging the ozone layer severely. That is, when 1 kilogram of R12 refrigerant leaks, it causes the same damage as 10 tons of carbon dioxide. So, they banned the buying and selling of R12 refrigerant after that. Now, R12 refrigerant is not manufactured anywhere. R410A, R134 refrigerants were invented instead of these refrigerants. Hydrofluorocarbon chemical is used in these refrigerants. It does not affect the ozone layer. Now this refrigerant is being used in most AC and fridges. A refrigerant must have certain properties. Its important properties are: boiling point should be low. There should be high critical temperature and high latent heat. There should be high thermal conductivity. Should not cause any harm to the materials. Must not be flammable or explosive. Should not be poisonous. Should be cheap and readily available. There should be no harm to ozone layer and the environment. Now, let's see how refrigerant works in an AC unit. The boiling point of R410A refrigerant is -45 degrees Celsius. That means it starts to boil at -45 degrees Celsius. If we put it in our hand, it will start boiling at the temperature of the hand. This refrigerant travels through all the equipment in the AC unit. First, let's see from the evaporator. Evaporator is the indoor unit of AC. When the refrigerant travels through the coil, the fan blower behind the coil continues to blow air. Then, due to the heat in this air, the refrigerant inside the coil will boil and turn into vapor. The cooling in the refrigerant will be transferred to the air. Then, this refrigerant goes inside the compressor. Refrigerant is in low pressure, high temperature, and vapor state before entering the compressor. After the refrigerant enters the compressor compresses the refrigerant well and sends it out at high pressure. Only then, this refrigerant can travel through all the equipments. When it comes out of the compressor, the refrigerant is in high pressure, high temperature, and vapor state. This compressor is inside the outdoor. After compressor, it goes to condenser. Condenser is coil in outdoor. When the refrigerant travels through this coil, the fan that is behind the coil blows air, and the temperature of the refrigerant decreases. Thus, when the temperature of the refrigerant decreases, the refrigerant changes from the vapor state to the liquid state. Therefore, when the refrigerant comes out of the condenser, it is in high pressure, low temperature, and liquid state. Then finally, the refrigerant goes inside the expansion valve. When the refrigerant passes through the expansion valve, its pressure will decrease. Due to decrease in pressure, its temperature also decreases a lot. Now, when the refrigerant comes out from the expansion valve, it will be at low pressure, very low temperature, and liquid state. Then, it goes back into the evaporator. Thus, it will continue. So, in this video, I hope you understand what refrigerant is, its history, characteristics, and the states of refrigerant in an AC unit. If you have any doubt, ask in comments. If you think this video will be useful to anyone, please share this video. Although we have heard a lot about inverter AC, most people are not clear about it. In this video, you can clearly understand what inverter AC is and how it works. If the set point is set to 23 degrees Celsius in normal AC, the temperature of the room will start decrease to 23 degrees Celsius. After the temperature of the room reaches 23 degrees Celsius, the outdoor unit of AC will cut off. When the room temperature rises above 23 degrees Celsius, the outdoor unit of the AC unit will turn on. This is a normal split AC working process. But in inverter AC, when the room temperature reaches the set point, its outdoor unit will not cut off. Instead, the speed of the compressor in the outdoor unit will decrease. Again, when the temperature of the room increases, the speed of the compressor also increases. This is the basic difference between normal split AC and inverter AC. Now, let's see about this in detail. As we have already said, in normal split AC, when the room temperature reaches the set point, the outdoor unit will be cut off. When the room temperature again exceeds the set point, the outdoor unit starts working. When the outdoor unit is cut off, the room temperature starts to increase rapidly. Then, when the outdoor starts running, the temperature of the room will decrease. As the outdoor unit turns off and turns on frequently, the temperature fluctuation occurs in the room. That is, the temperature of the room is not uniform and often increases and decreases, which is called temperature fluctuation. Apart from that, its starting current also high. As the outdoor unit turns off and turns on frequently, the starting current will be used more. So, this will increase the electricity bill, and its lifespan will also decrease. But there is no such problem in inverter AC. Now, let's discuss about it clearly. If the room temperature reaches the set point in the inverter AC, instead of the outdoor unit turning off, the speed of the outdoor compressor will decrease. Thus, the refrigerant flow is not completely cut, and the required amount of refrigerant continues to go to the indoor unit. So, the required room temperature is always maintained. Due to this, the temperature fluctuation does not occur in the room. Apart from that, the outdoor unit does not require much starting current, as it runs without being cut off. So, we can also reduce the electricity bill. Now, let's know the difference between normal AC and inverter AC. Inverter AC is more expensive than normal AC. The electricity bill can be reduced by up to 40% in inverter AC compared to normal AC. Inverter AC cools the room faster than normal AC. Temperature fluctuation occurs only occasionally in inverter AC. Temperature fluctuation occurs frequently in normal AC. Inverter AC repair cost is higher than the normal AC. So, I hope, through this video, you know what inverter AC is and how it works.